I got one more limits involving infinity algebraically problem over here. So let's take a look at this together. Oh, look. Gotta look for the biggest exponent in the bottom of the fraction first. Degree of the denominator is 3. So I'm going to divide. I'm going to write down my plan. Divide everything by x to the third power. Oopsie, where did that go? Let me bring that back up. Okay, I'm going to divide everything by x to the third power. All right, let's start then. So this equals limit as x approaches infinity of a gigantic fraction with like 7 things on top and bottom. First, this. Write down 2x cubed divided by x cubed. I'm done with the first one. Next, plus 5x squared divided by x to the third. Next, plus 4x divided by x to the third. Last one, minus 1 divided by x to the third. Okay, so I'm done with the numerator. I'm done with the top of the fraction now. I'm going to go to the bottom of the fraction. 3x squared divided by x to the third. Plus 6x squared divided by x to the third. And lastly, minus 7 divided by x to the third. Okay? And then after that, we will simplify this. Limit as x approaches positive infinity of... Alright, what happened to the first one? That will just be 2, right? Because x cubed over x cubed cancels out. So that's 2. But this one right here, one of the x survives in the bottom. So I will have 5 over x, right? Next. Plus. Well, the bottom has how many more x's left? The bottom has 2 more x's, right? This one only has 1 on top. So I will have 4 over x squared left when I simplify this. And let's do the last term on the top of the fraction. Well, I can't really simplify this. Minus 1 over x cubed. It's as simplified as it gets. All right, let's move to the bottom of the fraction. Start with that. 3x cubed divided by x cubed is 3. Plus, what about the second term? Let's see. This one. Look at this one. 6x squared over x cubed. Bottom has 1 more x. So write it as 6 over x. And this last fraction, it's already simplified. Just copy it down. 7 over x cubed. Okay. What I'm going to do now is I'm going to highlight everything that's going straight to 0. Okay? Anytime you have a number, an x or x squared, x cubed, like cousins of these x's in the bottom, they become 0. So that yellow highlighted fraction, 5 over x, is going to 0. 4 over x squared is going to 0. 1 over x cubed is going to 0. Because imagine dividing 5, 4, 1 by a really big number like infinity. They're becoming 0. Alright, the bottom of the fraction, that turns into 0, and this turns into 0. So if I simplify my work, this is equal to 2 plus 0 plus 0 plus 0, because I have these 3 yellow highlighted parts on top. And in the bottom, I have 3 plus 0 minus 0, right? And that is simply 2 over 3. 2 over 3. And that is, take a look, is the ratio of the leading coefficient, 2 over 3. And we get to use that method of just taking the ratio of the leading coefficients if the degrees of the denominator and the numerators are the same. That's something from Math 161 or pre-calculus. But I will ask you to show me all this beautiful work on your first exam, okay? Now in calculus, sometimes you may have more than one variable when you're working with limits. Okay, so I'll show you these 2 very quick examples. They're asking, find limit as h approaches 0 of this expression. So what you have to be careful is you're going to plug in h equals 0 only into h's. So where is h? Well, h is here and h is there. So don't be plugging in h of 0 everywhere. Like this x right there, that needs to stay as x. That's not h. So keep that as x. Plus 3 times x times 0 plus 0 squared. Okay, so let's simplify this. That is 3x squared. But look, that underlined, this, gray highlighted, that's just 0, isn't it? Because you're multiplying 3x times 0. This also, that just turns into 0. So guess what? My final answer is 3x squared. Okay, let's try one more. So they want us to simplify, find limit as h approaches 0. And you need to make sure that only h gets replaced by 0. This is equal to 1 over 2x times x plus 0. That is 1 over 2x times, well, x plus 0 is just x, isn't it? You're not adding anything to x, so that's just x. So we can simplify this one more step. This is same thing as 1 over 2 times x, which is x squared. So if you have more than one variable, make sure you're just plugging in to one of the variables that they want you to evaluate. Okay, so that's it for limits algebraically.